Hello geometers, and welcome to the lesson on perpendicular bisectors and the circumcenter. Now before we dive into this lesson, I think I should present a solution to the rec center problem, or the hospital problem, depending on which year it is that you're taking geometry. And the little caveat here is for two cities only. So this is, let's say you have only two cities. Let's call them London and Paris, and you wish to build a rec center between London and Paris that is equidistant to both. So the simplest and perhaps most obvious answer is to find the mid-segment. Not the mid-segment, I'm sorry, the midpoint. So I created a line segment between London and Paris. Then I just took a ruler and measured and found this point, and I will call this R for rec center. And of course R is a solution to the rec center problem. Okay. Now the key here is that it is not the only solution. Okay. It is a solution, not the only solution. So there are others. Okay. So one other solution that may work, and let me see if I can draw it out here, is another dot up here. And this red dot is also a solution. And just to prove it to you, I can take my ruler and measure this. It's about 4.5, and over here that's 4.5. Okay, so the red dot is also a solution, and I bet I can find yet some more. This blue dot here, also a solution. And we take a ruler and we measure it, and I'm sure that it will be exactly precise. Okay, the solution to this. So my claim here is that there are infinitely many solutions. Infinitely many. Okay. And all of the solutions exist. All of the solutions lie on this line right here. Okay. So all of the solutions are on this blue line. So there it is, the solution, the answer to the rec center problem for two cities. Now the reason I bring this up is because this answer will guide your thinking into solving the problem for three different cities. With these types of problems, they're very difficult, they're very frustrating. If you found yourself frustrated while you're working on this, you are normal. That's what everybody feels when they're working on a difficult problem like this. But they're worthwhile because they stretch your thinking and they make you a better thinker, a better problem solver. Okay. And one of the strategies to solving problems is to solve a simpler solution before we approach the more difficult one. Now I'm going to come back to this a little bit later, and I'm going to explain how I found this blue point, this red point, because it's not always the case that that is true. Yeah. So let's move on and let's talk a little bit about some vocabulary here. A segment, ray, or plane that is perpendicular to a segment at its midpoint is called the perpendicular bisector. A point is equidistant from two figures if the point is the same distance from each figure. So let's just talk about perpendicular bisectors here. So if I have some generic line segment, let's call this AB, and then I find the midpoint, and then I draw a line perpendicular to it. Then we can say that this is line L, that L is a perpendicular bisector of segment AB. Okay, that's what the definition of this term means. Okay. Now let's move on and let's talk about a little theorem here, theorem 5.2, perpendicular bisector theorem. In a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segments. So this just says let's just kind of redraw the segment here. Let's say I have a segment AB, okay, and then I find its perpendicular bisector, which is in here somewhere. And this says if a point is on the there should be that symbol for perpendicular and these tick marks because it's a bisector. So if a point is on this blue line, then it must be equidistant from the endpoints of the segments. So let's say I put any point. Let's put this point here, C. Okay. So the theorem says that CA is congruent to CB. That no matter where you place the point C, as long as you place it on the blue line, it will be equidistant from A and B. In other words, wherever C is, CA will be congruent to CB as long as it is on the blue line. And I'm going to prove this for you. So the last statement, so I'm going to actually prove this using CPCTC. So the first thing I'm going to, the way that the proof is going to finish is that I'm going to say AC, sorry, is congruent to BC by CPCTC. Okay. And I'm going to work backwards from there. I'm going to call this point down here D, and I'm going to show somehow that triangle ADC is congruent to triangle BDC. Okay. And then I'm going to start putting the pieces together. Well, from the picture, we can see that AD is congruent to BD. BD. Okay. Because D is the midpoint of AB. Okay. Then we can see here that we have two right triangles. This one and the one that's a linear pair with it. So angle CDA rather is congruent to angle CDB, because they are both 90 degrees. And finally, I have a length in the middle here, CD and CD. So CD is congruent to DC, and that is reflexive. Okay. So I have, what do we have here? We have a side, we have an angle, and we have a side. So the triangles are congruent by side angle side, and then these two segments are congruent by CPCTC. Okay. And that's the end of this proof. Now let's go back, just backtrack just a little bit to this problem. Okay. The solution to the rec center for two cities. Well, there are infinitely many solutions, and I should say on the blue line. If the blue line, I should name this, we'll call this L. If L is perpendicular to, let's name this point L for big L for London, let's call this P for Paris, let's not call this L, let's call this little m. If line M is perpendicular to line LP. Well, why must this claim be true? Because of this theorem down here. If you have something that is perpendicular and a bisector of these two segments, then every single point on this blue line is equidistant to the endpoints. Okay? And this is the solution to the rec center problem or the hospital problem for two different cities. I should say that if you think about this and extend this idea, you'll be able to find a solution for 3 cities. Okay. And as always, keep working at it. It's a difficult problem, but it's going to stretch your thinking and make you better at problem solving. Ask for help if you need it. Thank you for watching. Have a wonderful day.